Implementation of leveling. Hi there. In the previous lessons, we have learned about the layout of three different leveling lines, which are closed leveling line, annexed leveling line, and spur leveling line. Today, let's learn how to implement leveling. First, let's learn some leveling methods. Leveling method. When the elevation point B to be measured is far away from the known benchmark A or the gradient is large, several vertical ruler points need to be added between the 2 points as transition points for transferring the elevation, which are called intermediate points, TP. These intermediate points divide a line into several sections. Then place instruments successively to measure the height difference of each section, to determine HAB and calculate the elevation of point B. As shown in the figure below, the elevation of benchmark point BM.A is known, and the elevation of point B is to be determined. The elevation of point A is known to be 123,445 m. From the figure, we can find the number of survey stations. That's right, there are 4 survey stations in total. The forward and back ruler readings of each station have already been provided. So, all we need to do is to calculate the height differences for all 4 stations and sum them up. Then, the elevation of the unknown point B is obtained. Do you remember the formula for calculating the height difference? Great! Use the back reading to minus the forward reading. Observation method. 1. Place the instrument at a point with equal distance from both the back sight point, A, and the front sight point. 2. Roughly level the instrument. 3. Aim at the back sight point A, finely level the instrument, and read the back reading A1. 4. Aim at the back sight point TP1, finely level the instrument, and read the back reading B1. Then the height difference of the first station is H1 equals A1, B1. 5. Same method is used to observe each station and calculate the elevation difference. HB equals 123,446 plus 0408 equals 123,854 m. The recorder should promptly complete the calculation and verification items on each page of the logbook on site. i.e. HAB equals sigma A dash sigma B, HAB equals sigma H. Next, let's learn about the recording method for leveling. 2. The recording method for leveling. During leveling, the observation readings should be recorded on the logbook. The table for recording general leveling results is shown in the figure below. Calculations and verifications are performed in the leveling record table, which can only check if the calculations are correct, but cannot check if the observations and records are correct. In order to discover errors of observations in a timely manner and ensure the accuracy of height difference observations at each station, the station verification can be adopted. 3. Station verification. First, let's take a look at the leveling verification. Station verification. Check the observation results at a station. 1. Height difference of 2 measurements. Variable instrument heights method at a same observation station. By changing the instrument height, 10 cm, get the height difference of 2 measurements. If the height difference falls within the allowable range, plus or minus 6 mm for class 1 leveling, plus or minus 5 mm for class 4 leveling, take the average as the height difference for that station. 2. Double-sided ruler method. At a same survey station, with the instrument height unchanged, get the height difference of 2 measurements obtained using a ruler's black and red sides respectively. If the difference falls within the allowable range, plus or minus 6 mm for class 1, plus or minus 5 mm for class 4, take the average as the height difference for that station. Next, let's take a look at the leveling line verification. Station verification can only check if the height difference of a station is correct. But for an entire leveling line, it is not enough to indicate whether its accuracy meets the requirements. For example, if there is a significant change in the intermediate points from the end of observation at one station to the beginning of observation at another station, it cannot be found through the station verification. but it can be indicated in the leveling line verification results. Therefore, it is necessary to carry out the leveling line verification in order to ensure the correctness of the observation results along the entire line. Okay, that's all for the implementation of leveling lecture. What are the steps for leveling? Right, observation, recording, calculation, and verification. In the next class, we will learn about the internal work calculation of closed leveling line. I hope you will review after class and bring a calculator next time to complete the observation and calculation tasks together.